We're going to do a quick session here on a pattern generator. Just so happens to be a function of the Analog Discovery 2. It's a very useful function in the training environment, and you could also use it in the testing environment. And the Waveforms software is where we're going to spend most of our time showing you how that works. First off, a pattern generator probably could be compared to something's a little more known, like a signal generator in the analog world. In the analog world, sometimes you want to create signals like sine waves and sawtooth waves and square waves, and you want to adjust them any way possible, center them on 0 volts, or have them go from 0 to 8 volts or 0 to 12 volts. You would use a signal generator for that. They're usually limited to 1 or 2 channels, and it's a standard piece of test equipment that you find on a workbench. A pattern generator differs in that the signals that you create are for the digital logic environment. So you're creating a signal to apply to the input to a logic IC. Perhaps you want to exercise an AND gate, and you want to create those signals to do that and see how they work in the learning environment. That's what you use a pattern generator for. Not a very common tool. As I said, very, very helpful in teaching people about digital logic. In the troubleshooting environment, signal generators and pattern generators aren't used too often. So the other advantage of a pattern generator is it has many channels. In our case, up to 16 channels can be used to generate patterns at one time, and you could not do that with a signal generator in the analog world. So let's jump in and try and explain this a little bit. I have my waveform software started, and I'm going to choose the pattern generator. When I click on that, up comes my window. And I'm going to start out with just showing us one channel that we generate at a time. So I'm going to click the button to add. I'm going to choose a signal. I'm going to click on that. And I'm going to add channel 0. And it's going to come up on the screen. The first thing that we need to do when we do a channel is choose the type of output configuration. And almost always we're going to do push-pull when we're hooking these signals up to the inputs of AND gates and OR gates, just regular logic ICs. The other thing, generating a constant voltage of a 0, which is what you see happening right here, and I could change that to generate a constant voltage of 1. That's not the most exciting thing. I could hook a wire up in my breadboard and do that by just running the wire from the supply rail over. So if I choose the type of signal and I choose clock, it's going to generate a clock signal at 1 kilohertz. I also can generate pulses, and I can change the width of the pulse that I want here. We'll look at that a little bit later. But there's a lot of different things you can do. Random signals and custom, which lets you actually set up and create your own signal. And once again, we'll show you that just a little bit later. So that gets you an idea. By the way, once you turn this on and run this by clicking this green arrow up here, that means that this signal is going to come out the DI00 wire of your Analog Discovery 2. So that gives you a quick introduction. Let's go to something that's a little bit more interesting to work with. So if I pull down on the minus button here and I clear all these signals off, what I want to do is add a set of signals. In this case, that would be a bus or a group of signals. Terminology is pretty the same. So I'm going to select this one, and I'm going to hold the shift key down and shift select all of these and click add. And everything else I'll leave as default. Once again, I want to set the outputs up for push-pull, and I don't want to have a constant voltages here. I'm going to use a binary counter. It's a pretty organized signal to generate. And what a binary counter does is generate counting signals. And if I have 4 bits, 2 to the 4th is 16, and I'll count from 0 to 15. That's 16 different counts, and that's what you can see here. Here is a count of 0 where all the bits are 0. Here's a count of 1 where the least significant bit goes to a 1, and this continues on in binary counting sequence. This little summary at the top is really great. It's a decimal representation of these 4 signals at any one time, and that's a big time saver for technicians. By the way, if you come over here and you click to edit that, you could change the format to hexadecimal, say, and it's going to show you hexadecimal numbers up here instead of decimal. Let me change that back quickly because I want to stick with the decimal representation, since that's a numbering system that most people understand. Okay, there are other kinds of signals that you can generate. Here's a gray counter signal. It's a minimum change code, so from one sequence to other, only 1 bit changes. You can change to a Johnson counter. Has applications in different areas. You can choose random, so that you can just exercise the things and you can do whatever you want. The other thing that you can choose that's interesting is custom, and that lets you create your own signals. So when you create a custom signal, you have to go in and edit the signal that you have. So if you see this little pencil icon here and I click on that, that brings up the editing window for custom signals. And I have my 4 signals sitting here again, and I have a really nifty little interface. You can see when I hold my cursor here on this thing, it says 1, and I'm just left dragging the button as I go there, and I'll click off of that so it's there, and you can see it created a 1 signal here. If I wanted to create a 1 signal on this thing, all I do is go to where I want it to start, hold the left button down, drag it as far as I want, and I do it. Let me click this off that selection for you. Now say that's a little bit too wide, you don't want as wide a signal there. You can see I'm holding my cursor in an area that would represent a 0 for this signal, and I drag that over and it alters that to 0. And you can do that for all the signals that you want, however you want them. One thing that you might want to do is have all 4 of the signals line up a 1 at the same time, and that's hard to do. And they did put something in the software for that. So if I take my cursor, go to the very top, and go on the 1 signal, you'll notice when I drag this over, it does a 1 all at the same time, and the edges line up exactly, and that's what's hard to do manually with eyeballing it. So you can line them up all exactly, and say you didn't want all 4 of these to be start as a 1, then you could just go back down here and edit these 2 out and do it. And that, when you close this, that generates your custom signals for you. Really great feature, and do it. So very quickly here, how would I use this? Let me change to a different window here, and say I wanted to create 4 signals to exercise this 4 input AND gate. Here's the truth table for this. I just used 2 input AND gates to create that. That's a very classic thing to do. The signals that I generated, I would hook to the pin 1 inputs, the pin 2 inputs, the pin 5 input, and the pin 10 inputs of the ICs. These would be the 4 signals I'm generating as inputs to apply to the circuit. And then I would want to see what the output is and make sure this entire circuit functioned correctly by putting another output signal from the Analog Discovery 2 on here, hook that up and do that at one time. We're going to do that a little bit later. Let me go back to the Analog Discovery software screen, but we are going to do that a little bit later in another video. But just to show you very quickly, here's my analog discovery 2, and here's my signals coming from here. You can maybe not see as good as I can, but I have these labeled. Here's the 0 signal, the 1, the 2, and the 3 signal from the analog discovery 2. Those are the signals that I generated. Here is the 4th channel being hooked to the output of that circuit so that I could exercise it and take a look at these signals. And that's what you would use a pattern generator for. So in review, a bunch of digital signals. You can have standard patterns that are used to exercise circuitry, or you can create your own custom circuits, and you can have multiple signals that you create and you can apply them to a circuit, and then you can use the logic analyzer to look at the result.